Bismillah ar-Rahman ar-Rahim. Why do changes to the input have the opposite effect from what we expect? An important question, I believe, which explaining turned out to be a little bit more involved than I realized. And in this video, we're going to look at some visuals to help us understand why this happens. For example, the function y equals, in parentheses, x plus 2 squared shifts the parabola left instead of right. So let's take a look. So first of all, a diagram of basically how a function works. The parent function is y equals x squared, and that takes an input, for example 1, squares it, and then spits out the output. So if you input 1, you get out 4. If you input 2, you get out, if you input 1, you get out 1. Input of 2 gives you an output of 4. Input of 3 gives you an output of 9. There's nothing that we changed about this parent function, but we're going to do that now. So for example, if I apply a transformation on the output side of the function, what that does is whatever comes out of the function, in this case, I'll add 2 to it. So every single output was actually increased by 2. Let's take a look at what that does on a graph. We kind of saw what it does on a table, but let's take a look at what it does on a graph. So what's shown here is the parent function. Nothing changed about it, just taking the input and squaring it. We're going to apply a transformation to that where we add 2 to whatever output first came out. Let's see what that looks like. Let's take a look at the first row in this table, and the input on that row is 1, and so we see a vertical line right there at x equals 1 because that's where the action is taking place. First the output was 1, but after our transformation the output got increased by 2, and we can see what that looks like when we look at the graph as we go from original to new output. Let's look at the next row. The input is 2, and the output, instead of being 4, goes to 6. And let's do it in the third row. The input changes, or the output changes from 9 to 11. We can see visually what that did to those 3 points, and then if we look at what that does to the function as a whole, we'll see, well, if that happens to all the points, then the entire thing is shifted 2 units upward. That's a vertical translation. That one's a little bit easier to understand. Let's move on to making a change. Instead of changing the output, let's actually change the input. So somebody comes and says, hey, plug in 1 to this function. And then somebody else, there's a middleman now. And the middleman comes and says, whatever the input tells you they want, we're actually going to add 2 to it before we plug it into the function. So there's a middleman changing the input before it even enters the function. Alright, so we can see that happening here where when the original input was 1, we're adding 2 to that to make the actual input that goes into function 3. That's what gets squared for an output of 9. So when 1 came in, we actually got 9 out because the function sort of read 1 as actually being 3. When 2 came in, we got 16 out because the function squared 4 instead of 2. And then when 3 came in, we got 25 out because the function squared 5 instead of 3. Great, we can see what it looks like in a diagram. We can kind of see what it looks like in a table. But that still doesn't answer the question, why does all of that cause the graph to shift left instead of right? So let's get visual about this. Alright, so here we have the original function, just the parent function, inputs and outputs shown with the graph shown. The changes that we're making here are that our input is being increased by 2 before it actually goes into the function. So that's going to also change the output. So when 0 came in, the output was actually 4. Now let's start by kind of trying the same method that we tried before. Take one row, just focus on it, right? And then focus on where the input started out. It started out at 0. When my input was 0, my output started out at 0, and then it changed to 4. We can kind of see that on the graph. That point moves up by 4 units. Okay, great. That is what happened. We're gonna ask the question whether that's actually helpful for us to understand this. But let's move on to the next one. When the input is 1, the original output is 1, but the new output is 9. Okay, great. Again, that's true that what we are showing, the new points we are showing on the graph do represent the new transformed function. But the question we should be asking, what on earth does this have anything to do with adding 2? Because we haven't seen that. We haven't seen how that's showing up in this situation. So let's put everything back to where we started, and let's think about this differently. First of all, we're not changing the output, we're actually changing the input. So let's get rid of our kind of vertical guideline, and let's bring in a horizontal guideline instead. Right? Points are not moving up and down in this situation, they're moving left and right. Let's see why. Alright, so now we're still focused on that first row. The output for that first row was 0. But right now, instead of moving the original point up, I'm just going to take my guideline and go fishing for a point that has the new output. So I know that the output is actually going to be 4 instead of 0. I'm going to go fishing for a point that, that demonstrates an output of 4. And if I go, I find that it's right there, 4 units up. Okay, cool. Now, before we figure out what to do with that, let's see if this starts to give us a clue at where the +2 is coming from. So, earlier, just to remind you guys, we actually took that point at the bottom, and we said, hey, let's move that 4 points up and call that our new point. We're not going to do that. That point's going to stay exactly where it is. Instead, what might make sense is we take this new point that where we see the output is already 4. So we're not changing outputs, we're changing input. So the output for that point is already 4, right? And we could take that point and move it to where that first point originally, we originally saw that it had moved to, right? So let's see what that looks like. Okay, so I'm kind of showing now that that green arrow on the bottom shows the point that's actually going to move. We're going to move it to the left, right? And this is what it's going to look like. That's the point that moved. Now, the question we should ask right now is, what does this have to do with the whole +2? Well, when we look at another example or two, we'll see how +2 is actually, the transformation of +2 is actually showing up here very clearly. So let's look at the next row. The original output, when the input was 1, was 1. The original output was 1. The new output that I'm actually getting is 9. Let's go fishing for that new output. There's that new output. Hey, what's the x value for that output? Right? 9. Right now I'm getting 9, but normally I get 9 when the input is actually 3. Okay. So when the output that I normally get when the input is 3 is 9, that output, I'm moving it closer to the origin. I'm moving it more towards the starting point, so that it actually takes the place for the input of 1. So when the input is 1, I'm actually finding that what I'm having is the input I normally expect, is the output I normally expect when the input is 3. Let's look at one more example and see if this becomes even more clear. When the output is 4, right? Now, first of all, before we move forward, what we've seen before is that every time I look at one of these rows, I find that there was a point that matched up with that line on the blue parabola. Let me remind you guys, we used to have a point on the blue parabola right there, that green point, but we had already moved it over, and that's why we're not seeing a point right there. We already moved it so that it took the place of one of the earlier inputs. Okay, so that's gone. Now let me go fishing for an output of 16. Again, input right now is 2, and I want to find where is the output of 16. The output of 16 happens all the way up there, which I normally get with an input of 4. So that input of 4 is being shifted over so that it happens when the input is actually 2. When the input is actually 2. And I think this visualization really helps to show how some people describe this as a translation, a horizontal translation of +2. It's kind of like moving forward in time. It's like time traveling 2 hours forward, so that everything happens 2 hours sooner than it normally does. In this case, all the outputs happen 2 units earlier than they normally do. And that's exactly what we're seeing here. So let's clear all the clutter here and apply that to the final points. It would be the same idea. The same idea would happen to those points that we had shown, and then the entire parabola. Then, if that happens to all the points, the entire parabola actually shifts to the left. I hope that these visuals help show why this happened, and then describing it as kind of traveling forward in time also helps to understand how adding to actually shifts the outputs to the left, so that we see them in a position that's earlier, if we're using time as the example, than we normally would see them.